Okay, in this video, we are going to explore the LCM of x1, x2, x3 xn and the GCD of x1, x2, x3 xn. Before watching this video, I encourage you to watch the previous part of this video. So, this is like a generalization of the previous result. Okay, let's start. So, as we know, we can write x1 as the product of prime numbers raised to some power, and same for xn, x1, x2, x3, same for all xi's. Okay, so x1 equals, now here we cannot write p1 raised to the power alpha 1 p m raised to the power alpha m. Why? Because then you have to write x2 equals p2 raised to the power beta 2 pm raised to the power beta m. But you will be not able to write xn because there are not n Greek alphabets, so you will not be able to write this is p1 anything here. This will become blank, so we are going to write this in a new way and in a very nice way. So x1 equals p1 raised to the power alpha 1 comma 1. Now we can write all the n square powers, or no, not n square, m times n powers, all the m times n powers. Let me show you. p2 raised to the power alpha 1 comma 2 pm raised to the power alpha 1 comma m. For x2 you can write p1 raised to the power alpha 2 comma 1 times p2 raised to the power alpha 2 comma 2 pm raised to the power alpha 2 comma m. Nice. And continue this process up to xn. So xn equals p1 raised to the power alpha n comma 1 times p2 raised to the power alpha n comma 2 pm raised to the power alpha n comma m. So there are m powers of x1 here, m powers of x2 here, and m powers of xn here, and there are a total of n variables. So the total number of powers will be m times n by simple counting. So we can represent all the m times n powers in this way. If there will be m times n times p powers, then you have to do 1 comma 1 comma 1 and 1 comma 1 comma 2 like this. Okay, so this is the thing. Now you can get motivation to write like this from Holder's inequality, the generalized Holder's inequality. Okay, so you can see generalized Holder's inequality and learn how to write like this. Okay, let's keep going. Okay, here alpha I comma j belongs to non-negative integers for all 1 less than equals to I less than equals to n, comma 1 less than equals to j less than equals to m, and p lambda belongs to prime numbers for all 1 less than equals to lambda less than equals to m. Okay, So let's find out the LCM of x1 x2 xn. Okay, so LCM. So I'm going to write this full x1 in product form and x2 in product form, same for xn, because it will be quite complicated to write the full expanded form. So let me write everything in product form. And you know the symbol of product form. This is the symbol of product form, capital pi. Okay, so pi 1 less than equals to I1 less than equals to m of pi1 alpha 1 comma I1 1 comma I1 comma for x2 product 1 less than equals to I2 less than equals to m pi2 to the power alpha 2 comma I2 dot the product 1 less than equals to in less than equals to m of pin raised to the power alpha n comma in. Okay, so if you have watched my previous video, then you know in LCM we consider the maximum power. Wait a second. So like in LCM, if we have to find the LCM of x1 x2 x3 xn, then we consider the maximum power of the same prime number alpha 1 comma 1 alpha 2 comma 1 alpha n comma 1. So the maximum of alpha 1 comma 1 2 comma 1 n comma 1. Same for p2 1 comma 2 2 comma 2 n comma 2, their maximum value. And same for pm. We consider the maximum power in LCM and the minimum power in GCD for the same prime number in the base. Let me show you. So here p1 raised to the power the maximum of alpha 1 comma 1 comma alpha 2 comma 1 up to alpha n comma 1. Then we'll write for p2, then p3 up to so on up to pm raised to the power the maximum of alpha 1 comma m comma alpha 2 comma m dot alpha n comma m. Okay, so let me show you. Wait a second. Yeah, now listen carefully. So here we consider the maximum of all these alpha i's. So p1 raised to the power alpha 1 comma 1, p1 raised to the power alpha 2 comma 1, and p1 raised to the power alpha 1 n comma 1. So we consider the maximum power, the maximum from all of these. Same for p2 and same for pm. Okay, okay, wait a second. Yeah. Okay, wait a second. So let's write this in product form, because this expanded form looks complicated. So let's write this in product form. So product 1 less than equals to k less than equals to m of pk raised to the power the maximum value of alpha 1 comma k comma alpha 2 comma k dot wait a second, alpha n comma k. Okay, I just wrote this full expanded form in simple product form. Okay, so this is the LCM of all of these positive integers. Now let's find the GCD of them. So GCD of, the only difference in GCD and LCM is we consider the minimum power in GCD. So GCD of 1 less than equals to I1 less than equals to m of pi1 raised to the power alpha 1 comma I1 comma 1 less than equals to I2 less than equals to m of pi2 raised to the power alpha 2 comma I2. Okay, wait a second, 2 comma I2 and up to product 1 comma in less than equals to pin raised to the power alpha n comma in. So let's find the GCD of these. So in GCD we consider the minimum power. So let me write p1 raised to the power the minimum value of alpha 1 comma 1 alpha 2 comma 1 up to alpha n comma 1 dot pm raised to the minimum value of alpha 1 comma m dot alpha n comma m. Okay, now let's write this in product form. So this will be 1 less than equals to k less than equals to m of pk raised to the minimum value of alpha 1 comma k comma alpha 2 comma k up to alpha n comma k alpha n comma k. And you can easily check this by like an example. Let's take an example. GCD of 2 to the power 2 times 3 to the power comma 3 to the power 3. This will be 2 to the power 2 times 3 to the power 0 comma 2 to the power 0 times 3 to the power 3. As I told you, we consider the minimum power, so the minimum will be 2 to the power 0 times 3 to the power 0. This will be 1. And everyone knows that these two integers, positive integers, are co-prime to each other, so we get the GCD 1. Okay, so wait a second. Okay, so we figure out the GCD and LCM.